Hi, in this video I'm going to go over an example that is asking us to show that 3 points are collinear. Okay, this is a very common question that you'll be asked about vectors, is to prove a couple of points are collinear. So in order for us to do this, we need to know what does collinear mean. Okay, so collinear points are points on the same straight line. Okay, they're on the same straight line. So for example, if I kind of sketch this out, I have a straight point, I have a straight line, and I have points A, B, and C. Then these 3 points are collinear. Okay, but it has to be a straight line. All right. So if you think about this, before we apply collinear points on vectors, let's look at collinear points on the xy plane. Alright, so I have maybe just make myself a straight line, and I have 3 points. So this is my point A, my point B, and my point C. How can I prove that these 3 points are collinear? Okay, now this is a straight line, right? Let's say this straight line has an equation of y is equal to, just for example, 2x plus 1. Just for example, right? So let me ask you, what is the slope of AB? What is the slope of BC? I hope your answer is the slope of AB is equal to 2, because they are on the straight line. They're on the same linear line, and the slope of BC is also equal to 2, right? This is the slope here. This part, with the slope of that part, would be the same as the slope of that part, because any point on this y is equal to 2x plus 1 will have a slope of 2, right? So that is the slope. Is one of the characteristics of collinear points. If the points are on the line, then the slope between any point, so even if the slope of AC would also be 2. So the slope between the points on the same straight line would be the same. In this case, our slope is 2, so they are all 2 over here. Now there's one more characteristic that we need to show, right? There's one more. So if they're on the same straight line, then I can say that this AB is part of it, and this BC is the second part. So this point B is sort of, that point B is the common point. Common point, right? So we can sort of look at this as AB is one small section, and that section is connected to my section BC because I have a point B being the common point. So if we're trying to prove that the points are collinear, the first thing we need to do is to look at the slope. The slope must be the same. Okay, and then the second part is they should have a common point. Alright, so based on these two must-have attributes of collinear points, we're going to apply that to our example here. Okay, so my position vector of A, which means OA, my OA is equal to 1, -2, 3. OB is equal to 2, equal to 2, -2, 3, -1. And my OC is equal to 4, -7, and 7. So we need to prove 2 things. The first one is the slope is the same. The second one is a common point. So let's choose. For the slope in terms of vector, instead of talking about a slope, we'll be talking about If you think about this, having the same slope in terms of a vector would mean the parallel, right? If two vectors are parallel, we are kind of saying that they have the same slope in some sense, right? So since we're talking right now, the context is vectors. Instead of talking about the slope, we'll be focusing on if they are parallel or not. Okay, so I'm going to erase this. All right, so now let's try to pick a point. Pick a point being the common point. So let's try to pick point A. I'll choose A as the common point. Okay, choose A as the common point. Okay, so which means my AB should be the same as, or maybe not the sorry, not the same. Should be parallel to my AC. Right, let me change that. AB is parallel to AC. Right, so my point A is now my common point. We need to prove this. If I can prove this, then since I have point A being the common point, then now I have proven that ABC point, the points ABC are collinear, right? So let's find out what's AB. AB is equal to AO plus OB, right? So AO is just the negative, the opposite of OA. So I'm just going to skip a few steps here. I'm going to put -1, 2, and -3, right? The opposite of that, plus -2, 3, and -1. And this is equal to -3, 5, and -4. Okay, so now let's find what's AC. Vector AC is equal to AO plus OC, right? So again, my AO is -1, 2, and -3. My OC, my OC is 4, -7, and 7. So my vector AC is 3, -5, and 4. And it turns out my vector AB is actually not only parallel, it is actually equal to my vector AC. Therefore, they are parallel and equal. Actually, they're equal, right? Which means points ABC, B, and C are collinear. Okay, so if you want to try on your own, try to go for a different common point. Maybe you can choose point B as your common point, and you can see if AB, vector AB, is it parallel to is it parallel to your vector, maybe vector BC. Verify that, and then you can give point C a shot being the common point, and verify if AC is parallel to your BC. Okay, all right, I'll see you guys in the next video.